Welcome back, ladies and gentlemen. It's a pleasure to see you, even though I'm not really looking at you, but I'm glad you're here all the same. This is going to be sweet. Last time we talked about systems of equations, talked about all the different ways that we have to solve them, except for one way, which is using something called a matrix, which may or may not sound familiar to you. So we did graphing, we did substitution, we did a couple different types of elimination. We're going to add matrices to that as our last little hurrah in just how to solve matrices. My goal after you watch this video is you'll be able to use the matrix method, which involves setting them up correctly, understanding what's happening, and then actually doing the math in Desmos, which will be in a second chunk of the video. So we'll keep this first one shortish. Number one, what's a matrix? Matrix is an array of numbers organized into rows and columns. Pause the video if you need to write that down. Here's what it looks like. A equals, and then you get those square brackets. And in this case, we've got 6 numbers in there, 1, 2, 3, 4, 5, and 6. And the numbers can be anything. They can be positive, they can be negative. You can have fractions, you can have decimals. Pretty much any real number can go in a matrix. I'll even do imaginaries, but whatever. But this is a matrix, right? This is a matrix, and this is the kind of matrix that we're going to be dealing with the most. Matrices come in all shapes and sizes. Well, okay, they come in a lot of shapes and sizes. But if we're looking at this one, we're noticing it has 2 rows and 3 columns, right? 1, 2, 3 is the first row, 4, 5, 6 the second row, 1, 4 column, 2, 5 column, 3, 6 column, right? So two rows, 3 columns, and we always label a matrix with a capital letter. Okay, that's just one of the little norms that we follow. Always use capital letters for matrices, and we would call this, since it does have 2 rows and 3 columns, a 2 by 3 matrix. So we would say that matrix A is a 2 by 3 matrix. Matrix A is a matrix with 2 rows and 3 columns. Okay, that's what a matrix is. Those are the nuts and bolts of it, right? Label it with a capital letter, how many rows, how many columns. Those are the big things we need to deal with. Okay, now with that all in mind, how do we actually use this to solve a system? So let's start off by looking at a system. Let's look at this one. 3x minus y equals -8, and 4x minus 2y equals -14. Okay, now a couple things I want you to notice about how this is set up. We've got 3x minus y equals -8, 4x minus 2y equals -14. And if you're following really close, hopefully you'll notice the x's are stacked on top of each other, the y's are stacked on top of each other, and then by themselves over here are the constants, just 2 other numbers that they're set equal to, right? The numbers with no variables attached to them, okay? That's really important because what we do when we're using a matrix to solve a system like this is we just transfer that information over into a matrix, okay? And I want you to stop and think for a minute, where did I get the numbers for this matrix? How did I know to put a 3 and a -1 and a -8 in the first row and a 4 and a -2 and a -14 in the second row? How did I know to do that? If you said it was because of the coefficients, yeah, that's exactly it, right? I just take 3, 3. -1, there's nothing there, so it's a 1. -1, -1, -8, -8. You just plug them in to that same 2-row, 3-column, 2 by 3 matrix that we talked about before. Again, there's other types of matrices that you'll deal with later, but those are this is the one that we're going to be using most. Okay, and then how do we solve a system using this information? What can we do with this matrix that is going to help us solve a system? Well, the truth is, there's an entire college class worth of stuff that you can do to do stuff with this matrix. And a lot of it's useful to help solving systems, and some of it is just stuff that you have to do if you're going to be a math major one day, which, you know, I mean, it's cool-ish. Luckily for you guys, I'm not going to make you do linear algebra. It's a lot of work. It's a lot. But once you do it, you end up with your answer. You get a matrix that looks like this. You start with your, what we call a coefficient matrix, our matrix that we make with our coefficients of the original system, do a bunch of linear algebra, and then plug it in to get all this. okay? And this actually has our answer in it. Now, how do you actually do it? Well, like I said, I first had to do it by hand in my linear algebra class, and probably a little bit of pre-calc, but ugh. Then I learned how to do it on the TI-84 graphing calculator, which mine wasn't even as nice as this. And since most of you guys don't own these, we are instead just going to use Desmos, because it turns out Desmos can do this too. And if you're thinking, hooray Desmos, good, because it's coming. So you're going to take your matrix, you're going to take your system. You're going to create a matrix from the coefficients. I'll show you guys how to do that. We're going to throw some magic into Desmos using something called the RREF, which stands for Reduced Row Echelon Form of Matrix A. You do not need to know that. And once we then have the calculator spit this other matrix back out to us with the 1, 0, -1, 0, 1, 5, that is ultimately going to give us our system. Okay, to not get too deep into it, basically what this is telling us is 1x equals -1 and 1y equals 5. So my answer for this system is -1, 5. If I were to plug -1 and 5 into these two systems, it would make them both true. And I did that using RREF on Desmos. Okay? If this sounds like a lot, good. It should. That way you'll appreciate how easy this is actually going to be once we get over to Desmos. So stop this video, move on to the next one, and enjoy.